All right, this is 5-4, day 1, which is called coordinate geometry, which means we're doing geometry in the coordinate plane. And today we're going to talk about two things. We're going to talk about midpoints and use a midpoint formula. And then we're also going to talk about distance and using the distance formula. Okay. So let's start with what is a midpoint. So a midpoint is a point that is exactly between two other points. So how could we do this on a number line? So how could we find the point that's exactly in the middle on a number line? So if this were a number line and it had like tick marks on it, I could start here and I could just keep working my way in. Like this would be on 6 and this would be on 12 and then 7 and 11 and then 8 and 10 and then down to 9, right? So I could count with my fingers. On a number line, but I don't always want to use a number line, and sometimes we make mistakes when we're doing stuff like that. So another way, the most logical way to do this is I'm trying to think of the number that's right in the middle of the two. In other words, the average. So to find the average of those two numbers, what we do is we add the numbers up and we divide by the number of numbers, which is just 2 of them. So we're going to add the numbers and divide by 2. Since there's only 2 numbers. Okay, so in this case, we would do 5 plus 13, and then we would divide that by 2. 5 plus 13 is 18, and 18 divided by 2 is 9. Okay? So that is going to come into play with the midpoint formula. So the midpoint formula, it says the midpoint of a segment with endpoints x1, y1, and x2, y2 has coordinates. Okay, so before I give you the formula, just so you know, this little 1 is called x sub 1. Sub meaning a subscript. Sub means below. So it's not an exponent or anything like this. This doesn't mean x squared. It just means the second x coordinate and the second y coordinate and the first x and the first y. So I'm going to use a capital M for midpoint. Okay, so to find the midpoint, what we really need to do when it's a diagonal line like this is we really want to find the middle of it horizontally and the middle vertically. So we're going to use this concept of averaging the numbers to come up with the midpoint formula. So if we're finding the average of the horizontal component, the horizontal letters are the x values. So I'm going to add those together, x sub 1 plus x sub 2, and I'm going to divide by 2, and that's going to give me the x coordinate of the midpoint. Then to find the middle vertically, I'm going to do the same thing but with the y coordinates. So it's going to be y sub 1 plus y sub 2 over 2. So this is the formula that we are going to use to find the midpoint, okay? All right, so let's use that down here. It says find the midpoint M using the midpoint formula and check your answer with a graph. So when I have these 2 points, I'm going to call one of them my x sub 1, y sub 1, and the other one x sub 2, y sub 2. And it doesn't matter which one is which. Okay, so I'll just call this my first set of coordinates, and then this will be my x sub 2 and my y sub 2. So we're going to use this formula here to find the midpoint. So I'm going to start by adding my x coordinates together. So my x coordinates are -5 and 3. And I'm going to divide by 2, and that will give me the x coordinate of the midpoint. And then I'm going to do the same thing with the y coordinates to find the y coordinate of the midpoint. So -2 plus 4, all divided by 2. Okay, so let's simplify that to get our final answer here. So -5 plus 3 is -2, and -2 divided by 2 is a -1. Here, -2 plus 4 is 2, and 2 divided by 2 is 1. So let's check by looking at the graph. So A is at -5, -2, and B is at 3, 4. Okay, I'm going to use a straight edge to go ahead and connect those. And now our midpoint should be right in the middle if we did this correctly. So the midpoint is at -1, +1, and there is point M. And you can see that it looks smack dab in the middle of points A and B. And even better, it is on the line. So the midpoint is always going to be on the line right in the middle. Okay, the next one is the same idea. Find the midpoint using the formula and check the answer with the graph. So with this one, I'm going to use this as my x sub 1, y sub 1, and this is my x sub 2, y sub 2. All right. And we're going to go ahead and use our formula. Now our x and our x, we're going to start with adding the x coordinates and dividing by 2. So our x's are -3 and +3. So -3 plus 3 and then divide by 2. And then we're going to do the same thing with our y coordinates, which are 4 plus 2, and divide by 2. Okay. All right, so now if I were to simplify those, -3 plus 3 is 0, and 0 divided by 2 is still 0. For the second coordinate, 4 plus 2 is 6, and 6 divided by 2 is 3. All right, so let's go ahead and graph our points. So the original one, C, is at -3, 4, and D is at 3, 2. So here's my segment. And now hopefully if we plot our midpoint, it should be on the line segment and right in the middle. So 0, 3 is here, and that's perfect. It's on the line segment and it is exactly in the middle. All right, we are not going to be doing these type of problems for today, so we're going to skip that. Okay, the next one is talking about how do you find the distance between 2 points on a coordinate plane. So there's a few different ways that we can do this, all right? I'll show you both of them. Sorry, I'm getting my notes out, that's why it's kind of loud. Okay, so first of all, here, I'm going to go ahead and write my reasons here. To find the distance between 2 points on the coordinate plane. Okay, so first thing we can do is if the segment is horizontal or vertical, we can just count. Okay, so if it's a horizontal line, we can just count the number of segments. Okay, another way that we could do this is we could actually use the Pythagorean theorem, which is back a couple of chapters. And that again is a squared plus b squared equals c squared. Okay, or the third way is we can use the distance formula. Okay, and in all honesty, this distance formula that I'm about to show you actually is the Pythagorean theorem. It's just using the x1, x2 concept. All right, so here goes. So we are going to take the x coordinates and subtract them, and then we're going to square it. And then we're going to do the same thing with the y coordinates and add that on. And finally, if you guys remember in the Pythagorean theorem, the last step was always take the square root. We're going to do that. All right, so this is my distance formula. All right. So I'm going to go back to my examples here. Okay, so here it says find the distance between L being at -5, and M being at 1, 3. And actually, that's this on this page right here. It's just this thing used to be a foldable, and it's not exactly going the best. So I'm going to say you can probably ignore this page 12 altogether. So you might want to even just cross that out. All right. So here we do need the coordinates though, and the coordinates of L was -5, -5, and then M was at 1, 3. Okay, so what I can do is I can take my L being at -5, -5, and call this my x1, y1, and M being at 1, 3, and call this my x2, y2 in the distance formula. Okay, so first of all, this distance formula, we're going to have a big old square root bar. And first thing we're going to do is we're going to subtract those x coordinates. So I'm going to start with -5 minus 1. And then we're going to square that. Okay, so be careful. The difference in the distance formula is we're using subtraction, whereas with the midpoint formula, we added the coordinates. If I were you, I would always be looking at this formula when you're doing it. All right, so now I'm going to do the same thing with the y's. So I'm going to take y1 minus y2, so -5 minus 3 squared. And now I have to evaluate this. Okay, so I'm just going to let you know that you can actually enter this in Desmos and it will come out perfectly. So if I were you, I would actually do that. So I'm going to actually split my screen here if I can. It's not really loving that. There we go. All right, Desmos. Sorry. There we go. Okay, so if I enter this in Desmos, I'm going to use the square root bar, and then I'm going to start with my parentheses, -5 minus 1, close my parentheses, and then I'm going to hit this squared key, and then I'm going to hit plus, and then my parenthesis again, -5 minus 3, close out my parentheses, and hit that squared key again. So Desmos will do it all for you because it does the order of operations perfectly. So it should be able to give you the answer, which is 10. Okay. All right, let's try another set. So what it's telling you here is this distance between L and M. The length of this segment is 10 units. All right, so now we want to find the distance between points P and Q. So I'm going to write those out here. So P was at coordinates -4, 2. And Q was at the coordinates 5, -2. All right, so I'm going to call this my x1, y1, and this one I'm going to call my x2, y2. And again, it doesn't matter which is which. I'm trying to find the length of this segment, which is really hard because it's diagonal. All right, so using my distance formula, it's going to start with a big, long square root bar. And looking up here, we're going to start with the x1 minus the x2. So that's going to be -4 minus 5. And that's going to be squared. And then plus, I'm going to do the y1 minus the y2. So 2 minus a -2. Be careful with that. And that's going to be squared. All right, my square root bar goes over all of that. So now I'm going to try that in Desmos here. So square root, use my parentheses, -4 minus 5. If you're using the keypad for that, the negative and the subtraction key are the same key in Desmos. And then I'm going to use the squared, and then plus, parentheses again, 2. Again, if you're using the keypad, you can just do minus a negative 2. And then we're going to square that one also. All right, this one is going to come out to a decimal, as a lot of them are. So we're going to go ahead and just round that to the nearest tenth, like it says in the directions. So this one is going to be 9.8 units long. All right, I have one more example of the distance formula for you today, and then I'm all done. So finding the length of segment FG, F was at the coordinates -4, +4. And then G was at coordinates -1, -3. All right, so last time, again, I'm going to call this my x sub 1, y sub 1, and G is going to be my x sub 2, y sub 2. So I don't get kind of crammed in here. I'm going to do the distance down here so it doesn't get overcrowded. Okay, so big square root bar. I'm going to start in the parentheses again, x1 minus x2 squared. So here's my x1 and my x2. So -4 minus a -1. Be careful when the second number is negative. A lot of times it gets messed up that you forget to write minus a -1. All right, and then we're going to add in the middle, and then we're going to subtract the y coordinates for the second part of the formula, y1 minus y2 squared. So 4 minus a -3, and that's squared. All right, now we're going to go to Desmos and let it work its magic. So big square root bar, -4 minus -1. Whoops. Squared. And then I have plus 4 minus a -3. Squared. It does not like my little thing that I've got going on here. There we go. Okay, so if I were to round this one to the nearest tenth, that would end up being a distance of 7.6. And that's it. That's all there is to using the distance formula. It's very tricky, easy to get confused if you don't look at the formulas while you're doing them. So I strongly suggest you always have the formulas out when you're working through midpoint formula and distance formula.